Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness of fit test using a pairwise goodness of fit test and Microsoft Excel. I have my own add-in that can actually do this very easily. I have a separate video on that, stikpet E, where I just need to type in that function, which then becomes available the data, and it does that whole post-hoc analysis for me. But in this video I will show you how you can do it without. I have some data in column A about marital status. It was taken from the General Social Survey from 2012. And the first thing I do is I'm actually counting how often each of the possible categories occurred. I also gave each of them an index that might be useful later on. And by simply using count if, you can then actually just get those results. You might notice that my Excel is using a semicolon to actually separate parameters. In your version that might be slightly different. The total sample size is then also easily obtained with a sum. Next, I determine the number of categories, which is in this case simply 5, or I can just count how many frequencies I have. And the expected proportions. So in this case, I'm going to say, well, these are my expected counts. Otherwise, what you could do is just divide this by the number of categories. So in that case, you would get for each of them, instead of typing it in, you would actually say, well, it's going to be this one divided by that one. But in this case, I'm using actually some predefined expected counts. And then the expected proportion is simply the expected count divided by the total of expected counts. Next, we determine every possible combination of two categories. So I can start, of course, with category 1 and 2. And then here I'm just going to go for 1 and 3, 1 and 4, 1 and 5, all the way until I reach 4 and 5. And then show actually those by using a VLOOKUP, so that this is actually looking up in here. That's why I had those indexes, and then returns to me the second column. I then also look up the sample size from each of these categories and the sample size for the pair, so that's just the sum of these two. So this is again just the VLOOKUP of now this one, and return to me the second one. The sample size is then simply the sum of these two. Alright, then we adjust the expected counts for each possible pair. So first I use a VLOOKUP to actually simply look up this one, or actually this one doesn't really matter, in now my expected proportions table, and I do that for both of them. Then the adjusted is simply taking the first one and divided by the sum of the two, and the other one is then of course the rest, which should actually also be 1 minus this one. So the adjusted proportions, then I can also do the adjusted count, which is then actually the adjusted proportion, expected proportion, multiplied with the sample size for the pair. Alright, then I need to determine the chi-square value. I have separate documentations for each of these, so if you're doing a Pearson test, a Neiman test, a Freeman-Tukey, or a G-test, or mod-log, or a power divergence with a specific lambda, so you can use any of these tests. The first thing I do is actually for the Pearson chi-square, I use the difference between the observed and the expected counts. So the observed count is over here and the expected count is over there. Square that result and divide it by the expected. So each of these will have a slightly first different ones, and then the chi-square value is just the sum of those two. Lastly, I then need to determine the p-value. So first I need the degrees of freedom, which is simply in this case always 1, because I only have 2 categories, so -1 would be just 1 for all of them. Remember, each of these rows is actually a test. So I can then use the function from chi-square dist right tail from Excel itself, and then just take the chi-square value and that degrees of freedom. And these are all our p-values then. We might want to adjust that depending on which method you want to use for adjustments. But for example, one of them is fairly straightforward, the Bonferroni, which just multiplies it with the number of tests that we've actually done, which can be quickly obtained by just taking the number of categories and then combine, in this case, number of categories, semicolon, 2 or comma, depending on your system settings. So we have 10 tests, so we're actually going to multiply each of these, each of the p-values, depending on which test you've used, with 10. Now this might become bigger than 1, so, and that's impossible for a probability, so we're going to say, well, it's going to be, if it's bigger than 1, just do 1, and otherwise just do that calculation. Alright, and here it is. That's actually the final result. In this case, it looks like some of them are above the 0.05 usual threshold, and some are below. So for example, this one. So the difference between divorced and never married will have significantly different counts in the population. And that's it. I hope this video was helpful, and thank you for watching.